G'day, JD from FluxFocus. I thought I'd just show you something that I was working on, and here's the schematic of it. I have need to create a Tacho Pulser, a constant, well, it may not be an instrument cluster, but I'm just using that to test at the moment. It may end up being an engine computer that the input goes into. So in this diagram here, I've got just 12 volts protection diode and a little bit of power filtering, and just setting up an NE555 here, and there's the timing capacitor and the two timing resistors, and those are 20k variable resistors, just so I can change the pulsing frequency to whatever I need on the as the signal going into the computer or into the instrument cluster. And the thing about the signal for Tacho is that they tend to come from the pickups are coils, inductor based, so the pulses that are sent out are usually quite large, and in fact in a lot of instrument clusters you'll find that the first once the signal goes into the instrument cluster, the first thing that it hits is a series resistor of about maybe 270, 220, 300, 330 k ohms, so that's quite large, and that's to limit the current from that high voltage. But the signal still needs to be our signal still needs to be quite high, so in most cases 5 volts won't cut it, 9 volts won't cut it, and 12 volts may be marginal, but what in fact I think probably something more like 24 volts is probably more what you'd want, but I'm getting away with 18 volts here, and my input is 12 volts, or 11.5 volts, and but in practice in the car that'll be 13.8, so 13.2 or something like that. And that is going into, I haven't actually been explicit with the label on this part, but it's an MC 34063. It's a DC to DC converter IC, and it has this capacitor here is part of the timing circuit, and that's setting up our frequency, and here is the comparator input. So inside here is a comparator which I think is something probably the negative side input, I guess, has a 1.25 volt reference into it, and this is our resistor divider to set up the actual voltage output that we need. And there's the all-important boost inductor, Schottky diode, and the ripple capacitor. And so we're taking the pulsing output from the 555 and driving that with a NPN transistor, and so that'll pull down to ground and relax up. Sorry, I should say rather, the transistor will pull down to ground, and the resistor will pull up to the 18 volt output provided by the DC to DC converter. And that gets inputted into, at the moment anyway, this vehicle instrument cluster that I've been experimenting with here. So if I go to the camera, and everything's powered up down here, and at the moment we're sitting on about 1800 1800 RPM or so. And here's the circuit board that I've just put on Variboard here for the moment, and there's the 555, my two adjustable variable resistors, and all that in there is the is my DC to DC boost converter, and I'm just using an RF choke. The amount of current that I need isn't a lot, and if we watch the needle and I adjust one of the variable pots, you can see that that's moving up and down, and I believe that the setting that I need is going to be about 1800 RPM or thereabouts, or higher, but that's fine. Once it's in situ, I can play around with that a bit to get it the way I want. And so that's about it, and that's the lid that would end up going on top of that. It's a nice tabs on the side for screwing that down to somewhere inside the vehicle. So this is just an experiment at the moment, and it seems to be working. And the pulses that I'm seeing on the Crow, I might be able to twist it around here to see. Yep, there we go, and bring the trace down a little bit, and I'm on 5 milliseconds per division there, and my duty cycle, I guess, what's that, that's about 30% or something, 30% on, and that's working out just the way I need it for the moment. So there you go, just something that I was working on today.